Hello, in this video, let's look at how to solve a trigonometric equation. When we solve trigonometric equations, we follow the same principles we do in algebra. We try to simplify everything first, following the order of operations. Then we undo everything that is left using the inverse functions. And when we are done, then we should have a simple statement involving trigonometry that we still need to solve. Now, because trigonometric functions are periodic, they go on forever and ever. That means there is often many solutions, infinitely many solutions, unless somebody restricts our domain to something else, some other interval. So in this example, we are restricted from 0 to 2 pi. So from 0 to 360, 2 pi is 360 because pi is 180 degrees. So this is one rotation around the circle. So we are asked, figure out what are the angles theta that will make this statement true if we run around the unit circle only once. So let's look at this. First, we need to undo all of the operations that are still here. We cannot simplify this any further because on the left side, these terms are not like terms, so we cannot do any math on them, and that means there is no simplification to be done. So the next thing is to undo all the operations using the PEMDAS in reverse. So we undo addition, then we undo multiplication. So first thing, we undo the addition, we minus from both sides the 5, and that makes 3 sine theta equals to 3. To cancel the times by 3, we divide both sides by 3. So now we have sine theta is equal to 1. So the question then says, what angle should we use so that the sine, which is the vertical line, is equal to 1? Well, this is unit circle, so the most it can ever be is +1 and -1. So at which angle do we get +1? Well, that would be here, that would be 90 degrees, because if we're right at the top here, this length is equal to radius, which is 1. So our answer would be theta is equal to 90 degrees. And there is no other place on this unit circle where that happens, unless we go around it multiple times, and then we will be back to the same point again. But since we're restricted to go only once around the circle, this is all there is. And if we're asked to find the angle in radians, then we need to convert the 90 degrees into radians, and we remember that pi is 180 degrees, and we have 90 degrees, which is half. So we have 90 degrees, so we make it x, and all we need to do is cross multiply from here. So we have 90 pi is x times 180, divided both sides by 180. We get 90 goes into 180 twice, and that makes exactly pi over 2. So our answer is either theta equals to 90 degrees, if our answer is accepted in degrees, and if it is not, then the answer is theta is pi over 2. Now, with the calculator, let us see if we can convince ourselves that this is true. So here is the graphing calculator. We have to be sure that we are in degree mode because our answer is in degrees. So let's look at the mode and check. And it is indeed in degrees, so that is good. Now we need to type in the equation. So we'll type in the left side is 3 sine of theta. We don't have theta, it doesn't have to be theta, it can be any variable, so x would be just fine. And on the other side is 8. Now the original window is trigonometric window, zoom 7, so let's see if that helps. So here is our left side, but we are not going to see the right side because our window only goes up to 4, and our second half is up at 8. So we're not going to see where this crosses. So let's go to the window and adjust it. The x is the angle. So let's go from negative 360 to 360. That means one rotation around the circle. We'll count by 90 degrees. And then from negative, let's say negative 5 to positive 10, because our max is at 8. And let's see if that helps. So this once again is our left side. And then we will have the right side. And we want to know where they cross. Here's the right side. We are only interested in the positive from 0 to 360, that's this piece. So we want to know what this location is. And we can use the calculator, calculate intersect. So here is the first curve, yes. Enter second curve, yes. Do you want to guess? Yes, I do. So the answer is 89.997 is what the calculator thinks the correct answer is. Sorry, that did not help. So here is the answer, 89.997, and the actual answer is 90 degrees. So the calculator confirms that the answer is 90 degrees. And it wasn't exact because the calculator does not know the exact answer. It can only approximate. And that is why it's asking, do you want to guess? It doesn't say, do you want to know exact solution? Because it doesn't know what exact solution is. That's why it's very important to do the work by hand, to know how to do the work by hand. And that is it. That's all there is for this example. I apologize for this little interruption. Thank you for your time. If you have any questions on anything, please let me know. Take care.